All right, we are starting here part B-1 of the June 2018 Chemistry Regents exam. So part B1, just like part A, is all multiple choice. So even if you're not sure of an answer, at least put something down. And by practicing and going over the questions for yourself, you're putting yourself in a great position to do well. So let's get started. All right, I'm just going to scroll. And here we have question 31. And it's asking us which elements are present in this mixture. So we have what's called the bright line spectrum for several different elements, and we're trying to figure out what elements are in this mixture. It's obviously a mixture of two based on the answers. So both of the elements, their lines, need to be accounted for in this mixture. So right away, we're just going to move from left to right. And if I take a look at the first two lines here in my mixture, it matches up with element X. So I would go ahead and kind of check off, if you will, all of the other element X lines and make sure they're in the mixture. So this double line, this line, this line, looks like this line, and these two lines. All right, and then we need to find the other element. And so we're just going to play the matching game. Let me change the color here. Okay, so for the mixture, the next line here almost matches up with Z, but I don't have this first line for Z. So Z is out. They all have to match. All that's left is A and D. D doesn't have any lines except for two, and those lines aren't here, so they're not part of my mixture. So let's just double check A. Sure enough, A is here, A is here, here, and here. So it looks to me that the match is element A and element X. And of course, they don't have it in that order. They have X, then A, which is choice 3. Okay. Question 32 also has to do with these bright line spectra. And you're asked, each line in the spectra represents the energy. Well, it turns out that an atom goes from what we call the barking state. No, that's the ground state. That was, of course, J, ground state, where all the element, all the atoms of the element, their electrons are in the lowest energy levels. And then as an atom absorbs energy, electrons move away from the nucleus into what's known as the excited state. And then from the excited state, they return back to the ground state and release that energy. So the line of the spectra is representing the energy that is released as electrons move from higher back to lower, which is choice 4. So energy is absorbed, goes from lower to higher, but then energy is released going from higher to lower. Definitely going to see probably both or at least one of these questions again. Let's go to question 33. All right, now here in 33, we have a table. We're told we have ions, and we're given protons, neutrons, and electrons, and we're asked which ion has a charge of 2 minus. In other words, it's going to have 2 more electrons than protons. All of the electrons are the same, so I'm looking for the number of protons, to be 2 less than the electrons. In other words, 10 minus 2, which is 8. And the answer, of course, is A. Let's move on to 34. What is the approximate mass of an atom? That it contains 26 protons, 26 electrons, and 19 neutrons. You need to know the mass of the atom is located in the center, known as the nucleus, and we're talking about protons plus neutrons. So, of course, the answer is 45. All righty. Question 35. So we're asked to figure out the electron configuration for potassium atom in the excited state. Potassium, the symbol is K. If you don't know that, go to reference table S. On the periodic table are all of the ground state electron configurations. So let me show you what I mean, and then we'll come back. Okay, so the bottom left-hand corner for every single element here on the table, or at least most of them, you're going to see the electron configuration. We're interested in the electron configuration for potassium, which is K, which is 2881. These are all ground state, lowest energy levels available for the electrons in an atom. Now, let's go back to the question. Okay, so 2881 for potassium, that's ground state, that's choice 3, can't be. The actual answer is going to be choice 4. Now, the electrons need to add up to 19, which 2 plus 8 plus 7 plus 2 do, and it does not match the electron configuration for the ground state. So therefore, it's in the excited state. Choices 1 and 2 are not good choices. First of all, let's check the numbers. We got 2 plus 7, which is 9, plus 6, which is 15. That's not enough electrons. And then 2 plus 8, which is 10, plus 5, which is 15. Not enough. So there we have it, choice 4. Question 36. It's asking about the total number of neutrons in an atom of potassium 42. Okay, so I guess they liked potassium last year in June. So first of all, potassium, right, is element K. 42, this number is the mass number. That's protons plus neutrons. So what I need to do is subtract the number of protons. Remember, protons, that's your atomic number, and that is what I call the Social Security number for every element. Every element has its own individual atomic number or number of protons. So let's go back to that periodic table. Okay, so here is potassium, and it is element 19. That's the atomic number, the number of protons. That's what I need. Back here at the questions, 36. 42 is the mass number, 19 atomic number, 42 minus 19 is 23. Use your calculator. You can use it for the Regents. You don't want to make a mistake. Okay, for 37, we are given this reaction, and we're asked what is the number of moles of carbon that must completely react to produce 2 moles of C2H6. So I like to put the information above the equation. So I'm looking for the moles of carbon, that's X. When I have 2 moles of C2H6, now I'm going to make a ratio. I'm going to take the coefficient here of 2 for carbon, put that underneath the equation. The coefficient that's understood here is 1, and here I have my ratio. X over 2 is equal to 2 over 1. And then all I have to do is cross multiply and divide. So x times 1, which is just x, I don't even have to divide, and 2 times 2, which is 4. The answer is 4 moles. So by putting the information given above the balanced equation and then the coefficients below, and almost you're basically using the equation then as your line here and set it equal, you have your ratio. All right, question 38. You're given an equation and you're asked which type of chemical reaction. Well, here are the 4 major types, and take a look at the equation. I have an element and a compound, and it's forming an element and a compound. That is a single replacement reaction. You should know what all 4 look like. Synthesis is coming together. You only have one product. Decomposition is breaking apart. You start with one reactant. For double replacement, what's double and double replacement? Two compounds you start with, 2 compounds you end with. For question 39, we are given a chart with different elements and some properties, density, malleability, and conductivity. And we're asked the question, based on this table, which statement describes how two of these elements can be differentiated from each other? So what makes them special, or what makes them different? So here's the thing. You're going to have to go through each choice. So for number one, gold can be differentiated from tungsten based on density. So here's gold and here's tungsten. Well, they have the same density. You know what? That's not going to work because we want them to be different, right? Differentiated. All right, so that ain't working. Let's go on to number two. Gold can be differentiated from sodium based on malleability. All right, I'm going to make that a different color. So gold, malleability, yes. And sodium malleability, yes. So 2 is not a good choice. Then sodium can be differentiated from tungsten based on conductivity. All right, let's use purple. So I have sodium, it's a good conductor, and tungsten, good conductor. Nope, that ain't working either. So sure enough, it's going to be choice 4, but let's double check. We're going to switch this. Let's do red. Sodium can be differentiated from iodine based on malleability. Well, malleability for sodium is a yes, malleability for iodine is a no, and that is the answer. Okay, so it's as much a reading question as it is looking at the chart. Don't skip steps, just do everything in order, and you're going to do great. All right, let's move on to question 40. Okay, for question 40, we want to know what's going to represent a mixture. Well, a mixture means I have two or more substances, that's elements and or compounds, that are just physically mixed. So here's our little key. So let's check it out. 1 can't be the answer. This would be for one compound. The circles that are touching represent bonds. That's no mixture, it's just one substance. Same thing with number 2. It's just two different atoms. For number 3, I have an element here, right? And I have a compound. So sure enough, my answer is 3, and 4 would just be representing atoms of one element. So my answer here is choice 3. Okay, question 41. It says an atom of which element reacts with an atom of hydrogen to form a bond with the greatest polarity? Okay, so the greatest polarity means you have two different nonmetals with the greatest electronegativity difference. Now, all 4 choices are bonding with hydrogen. So it's really then just a question of which one of these 4 choices is the highest: carbon, fluorine, nitrogen, or oxygen. Now, you might right away know the answer because you've been told over and over again that fluorine is the most electronegative element. On a scale of 0 to 4, it is a 4. So the answer is actually fluorine. But let's say you didn't know. As long as you understand degree of polarity, you're looking at electronegativity, you can go to reference table S. So you can fast forward if you know the answer, but if you don't, let me show you how to use reference table S to answer this question. Okay, at reference table S, I go to the electronegativity column and I already made red marks for the electronegativity for carbon, nitrogen, oxygen, and fluorine. And sure enough, fluorine is the highest value. We would be subtracting these 4 numbers from hydrogen's 2.2. So the greatest difference is going to be for fluorine. That's your answer. Okay, we're looking at question 42, and we're looking for concentration. And we have 1.5 moles of NaCl in 500 milliliters. So I'm dealing with concentration. I'm dealing with a mathematical problem. Go to reference table B. Let's take a look. Okay, we have 2 concentration equations. The first one, parts per million, doesn't match what we got in the problem. We got moles of sodium chloride and milliliters of solution. Okay, looking at reference table T, we're looking at the concentration equations. The first one here for parts per million, it's asking for mass of solute and mass of solution. That's not what we were given. We were given moles of solute and milliliters of solution, which of course we can change to liters. So we're looking here at the molarity equation. Okay, so we have molarity is equal to moles, which is 1.5 over, now you need to know how to convert milliliters to liters. And even if you have to slide the decimal, right? King Henry's drunken uncle drinks chocolate milk. I don't care how you do it, you need to get to the right answer. So, King Henry's drunken uncle drinks chocolate milk. Oop, I'm having a problem here with my pen. I'm here. That's 500. But I want to go here to liters. So what am I doing? I'm moving the decimal 1, 2, 3 spaces. In other words, I'm going from 500 to 1, 2, 3. So it's 0.5 liters. So it's going to be 1.5 moles divided by 0.5 liters. Now do yourself a favor, put it in the calculator, because the answer here for 42 is choice 3. Sometimes students want to just take it and have it because they see 0.5, but it's in the denominator, so the answer is choice 3, which is 3 moles. All right, now that I made a mess, let me erase this and go on to 43. Okay, so in 43, we have 4 gas samples, and we have temperatures, pressures, and volumes, and we're asked which of the 2 gas samples contains the same number of molecules. They're going to contain the same number of molecules if they're at the same pressure, volume, and temperature. So I start taking a look, and 1 and 2 don't match, 2 and 3 don't match, 3 and 4 don't match, but certainly 2 and 4 have the exact same temperature, pressure, and volume, which is choice 4. So yeah, they have to be under the same conditions, and then it doesn't matter what gas it is. Okay, we're taking a look at question 44. We're already told we need to go to table I, and we're looking for the delta H value for the production of 1 mole of NO2, right, at 101.3 kilopascals and 298. So 1 mole of NO2. So let's get to that reference table. Okay, so we are looking for, as the question says, the production of NO2. In other words, NO2 is a product. You start going down the reference table, and sure enough, here it is. But NO2, this would be for the formation of 2 moles, you'd have to put 66.4 kilojoules of energy in, but it asks for 1 mole. So of course, instead of 2, take 66.4, we're going to do 1 is going to take 66.4 divided by 2, which is 33.2. So let's take a look and see if that choice is there. And if you check it out, here it is. It's choice 1. Let's move on to 45. Which equation represents an addition reaction? An addition reaction is an organic reaction. That's reactions, of course, with carbon. And addition means that I'm literally adding 2 molecules together. Kind of a synthesis reaction, not kind of, it is a synthesis reaction. So what's the reaction where we end up with only 1 product? There it is, choice 2. That seems so quick and easy for me to answer that. But that's because I know what the addition reactions, there's substitution, polymerization, there's different organic reactions that I know what to look for. You need to do the same. So you do have some work to do if you didn't know the answer about recognizing the type of organic reaction if you're asked about it. There's basic information that you're going to have to memorize for the test. So we're given a balanced equation, and in this reaction, each nickel atom, okay, so we're talking about nickel here. Is it losing or gaining electrons? Well, it's by itself here on the left-hand side, so its oxidation number is 0. Now on the right-hand side, right, it's combined with the chloride ion. Well, it's actually in solution, but look what you have. You have NiCl2. The chloride ion is going to be -1, and you have 2 of them. That makes nickel +2. So the oxidation number went from 0 to +2. It became more positive. Why? Because I'm losing negative charges or losing electrons. Your answer there is choice 2. All right, right away, 47. Which equation represents a reduction half reaction? Any reduction half reaction, remember, Leo, the lion goes gur, loss of electrons, oxidation, gain is reduction. So if we're gaining, it's going to be on the reactant side. So right away, you can cross out choices 1 and 3, and then the charges need to make sense. Choice 2 doesn't make sense. You're going to end up with a -3 charge on the left and a +3 on the right. So it has to be choice 4. So it's +3 -3, which is 0, and then Fe by itself is 0. Okay, a couple of more. Well, that didn't make very much sense, did it? Let's check out some more redox reactions. Question 48. So we're given a balanced ionic equation, meaning the spectators are taken out. During this reaction, electrons are transferred from. Well, electrons are going to go from what's being oxidized, right, losing electrons, to what's being reduced. All right, so let's figure that out. First of all, you have copper atoms, so that's 0, going to +2. So it's the copper atoms, or the solid copper, that is losing electrons. So it has to be the substances, first of all, that are your reactants, or the left-hand side. So it can't be choice 2, because it already became copper ions. That would be a product, and it can't be choice 3. So it's either copper to silver ions or silver to copper, and we know the silver goes from +1 to 0. The oxidation number is becoming more negative, right, because it gained. So it's got to be choice 1, right? All right. 49, which metal reacts spontaneously with the strontium +2 ions? For this, you want to go to reference table J. Don't guess. Take a look. Okay, I made reference table J ridiculously small over here so you could see it. And we want to know what's going to react spontaneously with strontium, but strontium as an ion. The choices are calcium, right? Let's see, cobalt and cesium and copper. Well, you have 3 below strontium and only 1 above. That is your answer, but let's make sure we understand why. Strontium is ion, cesium wants to lose electrons and become an ion worse than the strontium, so therefore it's cesium. So question 49, if you use the reference table in that case, you might not even really understand the chemistry, but you would still get the correct answer because 3 of the answers are below the strontium and only 1 is above. Whatever is higher on reference table J has to be in the atom form, meaning 0 oxidation number, in order to make something else react below it. That's an ion. All right, let's finish out part B-1 here of the June 2018 Regents with question 50. All right, so we're given a balanced equation, and we're asked the water molecule acts as a base because it, well, if it's acting as a base, it has to be with the alternative theory, which your teacher probably told you was Bronsted-Lowry theory, and Bronsted-Lowry theory bases accept H+. So the answer here is choice 2. All right, we got through part B-1. Now we have to go to the short answer questions, which is part B-2 and part C. Keep working hard.